Hi everyone, it's Mrs. Carneiro-Dias, and today we will be learning about another type of transformation called dilation. Previous to today, we have already learned 3 different types of transformations, which were all rigid, meaning that they produced congruent figures: translation, reflection, and rotation. Today, we're going to be talking about dilations. Dilations are a transformation that produces an image that is the same shape as the original, but not the same size. A dilation is similar to the original figure. So this is different from the transformations that we learned previous to today because each of those were rigid, again, meaning that they produced a congruent figure. And dilations do not produce a congruent figure. Instead, it produces a similar figure. So another important thing to note is that dilations are centered around the origin, 0, 0, unless otherwise stated. So when we are dilating figures, we will be hearing the term scale factor. And basically the scale factor is a ratio of the image length to the pre-image length. So if we ever need to figure out what the scale factor is, we're going to just use this ratio. If the scale factor is greater than 1, the figure will become enlarged. And if the scale factor is between 0 and 1, the figure becomes reduced. It'll be smaller. So fraction, decimal, that is between 0 and 1, so it would reduce the figure. Now, there is a type of a coordinate rule that we use for dilations. So the original point x, y will transform to f times x, comma f times y, where f represents the scale factor. So all we do is use multiplication between the scale factor and the original coordinates to find your image or new coordinates. Okay, so we're going to go on to the next page and do an example. So triangle ABC has vertices at 0, 2 for A, 4, 4 B, and -4 for C. What are the vertices of its image with a scale factor of 2? Okay, so since the scale factor is 2, that is telling us that we're going to take our original point and we're going to just multiply 2 times the x value and then 2 times the y value. So this is our coordinate rule. So if we know that A is at 0, 2, then that means A prime is going to be at 0, 4. We just multiply x and y by 2. If B is at 4, 4, well then that means B prime would have to be at 8, 8. And if C is at -1, 4, then C prime is at -2, 8. So the rule for the dilation, I actually already noted at the top, again, is 2 times the x value and then 2 times the y value. And now it's asking us to graph. So what we're going to do is graph the original and the image. So point A is at 0, 2. I'm going to label as I go. B is at 4, 4. And C at -1, 4. So connect. And you can create your drawings using Cami. You can either use, the line tool or just draw with your finger, whatever you're more comfortable with. Okay, and I'm going to use a different color to draw the image. So I'm going to plot 0, 4 is A prime. B prime is at 8, 8. And C prime's at -2, 8. Okay, connect. So here is my image, my dilated figure. And if you notice, it's definitely larger. And if we take a look at how much larger it is, if we were to, for example, compare, the base of the triangle, triangle ABC, if we look at, I'll choose another color. If we look at this length, so 1, 2, 3, 4, 5 units long, And then if we look at the length of the image, we see it's 2, 4, 6, 8, 10 units long. So we notice that it is twice the length of the original. And again, that's because we are multiplying by a scale factor of 2. Now, what I'd like you to do is please pause your video and see if you can do this example on your own. When you are ready, hit play and I will go over it. All right, so you should be ready to go over this try it example. Triangle XYZ, let's go ahead and plot that at 0, -2. Y is at -1, 2. And Z at 2, 2. Now it didn't even ask for me to graph yet, but I just like to graph right away. Whoops. Okay, what are the vertices of its image with a scale factor of 3? So if the scale factor is 3, I'm actually going to jump down here. What is the rule? So we're going to take our original XY coordinates, and if the scale factor is 3, we're going to multiply the X and Y coordinates by 3. So X, 0, -2, multiply X and Y by 3, we end up with X prime being 0, -6. And then Y prime, -1 times 3 is -3, 2 times 3 is 6, and then Z prime, 2 times 3 is 6, and of course 2 times 3 again is 6. So these are the image points. So now we're going to go ahead and graph that. So I'll use another different color. Okay, 0, -6 is my X prime, -3, +6 up here is my Y prime, 6, 6 is Z prime. So now I can connect my image points. And there we have a dilated triangle by the scale factor of 3. Okay, next, example 2. So quadrilateral PQRS has vertices at P -2, 4, Q 4, 4, and R 4, -2, and S -4, -4. It is dilated by a scale factor of 1/2. Okay, so now we have a fractional scale factor. What are the coordinates of the image? And then we're going to graph it. So before I do my coordinates, I always like to start off with thinking about my rule. So the X, Y values, what's going to happen is we're going to multiply them both by 1/2. So it's 1/2 times X and 1/2 times Y. And remember from the very first slide that we did together, we did mention that if the scale factor is greater than 1, it'll be an enlargement. But if it's between 0 and 1, then it'll be a reduction. The figure will get smaller, and hopefully that's what we will see here. So P prime. So if P was -2, 4, then 1/2 that would be -1, 2. Q prime. Q was 4, 4, so 1/2 that would be at 2, 2. R prime, 1/2 of 4 is 2, 1/2 of -2 is -1. And S prime, -4, -4 will go to -2, -2. Just multiply by 1/2 or divide by 2. Okay, so now we have to graph the quadrilateral and its image. So I'll go ahead and graph in red P at -2, 4, Q at 4, 4, R at 4, -2, whoops, and S at -4, -4. Okay, so I'm going to connect, trying to make the lines as straight as possible. Okay, so there's my quadrilateral. And now we need to create our image figure, so I'll choose a different color. So P prime is -1, 2. Q prime, 2, 2. R prime is 2, -1. And S prime, -2, -2. Okay, so now let's connect our image points. And here we have our image figure. And if you notice, if we compare corresponding side lengths, for example, I'll choose yellow. So from P to Q, this line segment is 2, 4, 6 units long. And then if we look at P prime to Q prime, this line segment is 3 units long. So it's half that segment, which makes sense and should happen because we are using a scale factor of half. So we have a similar figure to the original, but it is smaller in size. At this point, I would like you guys to pause and try this example. When you are ready, hit play so you can see how you did. All right, guys. So at this point, you should be correcting your work. Let's see how you did. Quadrilateral ABCD has vertices A, -6, 3, B, 3, 3, C, 3, -3, and D, -6, -6. It is dilated by a scale factor of 1/3. Okay, so another fraction. So let's see how you did. First of all, I'm going to write my rule. So xy will transform to 1/3 of x and 1/3 of y. Okay, so A prime. A was at -6, 3, so 1/3 of that would be -2, 1. B prime, 1/3 of 3, 3 would be 1, 1. C prime, 1/3 of 3, -3 would be 1, -1. And D prime, 1/3 of -6, -6 would be -2, -2. All right, let's go ahead and graph. So I'll graph the original in blue. -6, 3 is A. 3, 3 is B. 3, -3 is C. And -6, -6 is D. Okay, so we can go ahead and connect. This is our original figure. Okay, so now let's graph the image. I'll graph that in red. So the image, A prime is at -2, 1. B prime, 1, 1. C prime, 1, -1. And D prime, -2, -2. Okay, so let's connect. Okay, so we see a figure that is smaller in size, but the same shape. Okay, so it is similar, and I always like to just check out one of the corresponding side lengths. We see here that these two line segments correspond. So in the original figure was 2, 4, 6, 8, 9 units long. And in the image figure, it's 3 units long, which is 1/3 of 9. Okay, so now if you continue, there are 3 practice problems that I'd like you to try on your own, and then you will be submitting to your teacher on Google Classroom so that she can see how you're doing and see if you need any help with this skill. Good luck, everyone.